Hello, everybody, and welcome to Getting APIs to Work. Today, we say hello to Isabelle Mauny, Field CTO and co-founder of 42 Crunch. Hello, Isabelle. How are you doing?
Hello everyone. Very well, thank you for inviting me here. Great to be part of the show.
Yeah, thanks for joining. So today we'll talk about OWASP and generally speaking, the practical API security. So things that can go wrong with APIs. And I think there's no shortage of things that can go wrong. And you have a lot of experience in that. Tell us just a little bit about like 42 Crunch, like what are you guys doing and how did the company come into being and what are you doing on a day-to-day basis?
Sure. So for Tito Crunch, what we do is, as you would imagine, we're working on API security. We've taken an approach that we will talk about, I guess, during the show, which is to help I would say companies approach security a bit differently and ingrain security within their development lifecycle. There's a huge role in our platform for developers and the role they play into security and how they can help. So our idea is really that security should be part of the overall API lifecycle, all the way from design to production, and we cover that entire lifecycle and make sure that all the different teams that are going to be involved in that journey actually have a common language and can work all together on better security. It's at a high level what we do.
That sounds like a good idea to me. Let's get started with just examples of where, like let's say visible examples of where something went wrong with API security, because I think we all read about those things by now, somewhere in the media. Maybe it doesn't always say API, but these are API related things. So what are typical examples that you mention when it comes to people, asking us like, what is API security even about?
Yeah, well, there's really no shortage of examples,
Yes.
unfortunately, or which is a strong reflection on the problem we have right now, and why I think API security is a very hot topic at the moment, and people starting realizing we've created all those APIs. As one of my customers told me once, they say we're seeing these popping up like mushrooms all over our data centers. And we really don't have zero control over them. I don't know what they do, which data they expose. We get told very late about, hey, there's this stuff we're going to expose tomorrow, and it it
Could you
exposes.
please give it a check mark? It's like, I don't know.
Yeah, exactly, right. Like sign here, it's all good, right? So it's one of the reasons actually. So we're 42 Crunch, but there's one place we've created at the same time we created 42 Crunch pretty much. We also launched something called API Security.io that you may have heard about,
Yes.
where really our goal was education, right? It's really about spreading the word on learning from the mistakes that others are making, so reporting on those bug bounties and those breaches, docs, events, whatever it is that will help people really better understand what the problems are, right? So what are those problems? Well, the problems are exposing too much information through our APIs, is misconfiguring authentication authorization, it's forgetting we have created a version 3, but for version 1 is still there running and we let it run. And it still has access to our production data too, which is not a good thing. And the number one problem, and we'll talk about this when we talk about OWASP, really is a difficult problem linked to authorization, but we'll talk about that in a second.
Okay, and I'm looking forward to that. But before we talk about those individual problems, let's briefly talk about OWASP itself. So OWASP has been around for a long time. I definitely first heard about it as something that was about web application security, and I think that's still kind of their main thing. But like, what is the history of OWASP and how do APIs factor into that nowadays?
So really, the OWASP is a foundation that is dedicated to application security and helping people and educating again the vast majority of development, security people, etc., on what the problems are and how to address them. It has it has a wealth of information on many different topics. Like you don't know how to properly implement logging. When you do logging, it has a there's a lot of security related potential problems when you do login, like depending on what you're actually logging. So you have to think about security when you're doing login. How do you do input validation? How do you write properly into a connection between a mobile application and your apps? All of this is really written in the form of cheat sheets and documentation and presentations in the OWASP, right? So they're also very famous for this OWASP top 10 that I'm sure everyone has heard about. How this is being built basically is they take some data from multiple vendors that will report on what are the problems they actually see at their customers, and they compile that information together and they rank the top 10 problem in this OWASP top 10. Not only do they rank the problems, but again, they rank the occurrence, like how often this is happening, how critical this is, and again, what do you have to do to protect yourself from those vulnerabilities, right? So traditionally, we've had the OWASP top 10 for application, like traditional application security. And about 2 years ago, the teams came to the realization that APIs are different. They bring some different problems, and therefore we need a specific OWASP top 10 for APIs. And that's how the OWASP API security top 10 was born. We worked on that. There's multiple teams that have been working on that and collaborating. And that's become now the reference for API problems.
Yes, and so we won't go through all of the top 10, but they are, like you said, on apisecurity.io. I think that's a very good resource where you can read about all of them. What you've done, and I think that's very useful, is you've put those into some kind of buckets, it's like related fields of problems or these kind of things. So what are the buckets that you have identified that can be used to group those 10?
So yeah, to help explain a bit. So there's three main buckets that I see. One is a common pretty much between the traditional OWASP top 10 and API security, which are problems related to authentication and authorization, because we have those issues the same way. There may be the architecture and maybe the concepts of what we are using behind the scenes to do authentication and authorization are slightly different, but the problems are pretty much the same. Yeah. Now there's a new bucket, I would say, which is very specific to APIs, which is a data bucket, right? Because what are APIs doing? APIs are all about exchanging data. So it's no wonder that there are a lot of problems related to how this data is going to be exchanged, either because I'm going to accept too much data in, or I'm on the contrary going to return too much data out. And of course, the traditional injections problems, although we see those a bit less in APIs, right? And the last bucket is more about configuration and governance, I would say, like, for example, this problem of leaving version 1 running when version 3 is up, that would be part of that bucket. Or logging is a big part of that as well. So more related to how we operate and deploy our APIs.
In order to highlight or to describe these buckets a little bit more concretely, we could look at one example and then just look at what went wrong. So and we briefly discussed, like an example we could use. So let's dive into one example and look at what happened there and how it relates to those buckets. So could you just briefly talk about that example and give us
Sure.
It was recently in the news, right? So it's interesting.
Absolutely, and I think I like to call this one like my favorite problem of the year so far. And you may have heard about this social network in the US. It became famous for political reasons. It's called Parler. And basically what happened is just before Parler got pretty much shut down at the beginning of the year after all the events in the US, hackers really wanted to make sure the data in there will not be lost forever. So that's what happened there, and that's the breach. A little bit of data was evaded, just 70 terabytes, just a little bit. And the way this happened is basically a combination of factors. So it's one of the breaches that combines the most problems from the top.
It's a record.
Yes, they got, I think it's the first one that has been identified to have 6 out of 10 just for that specific breach, right? Just for that specific problem. Maybe they had other problems we didn't know about. But so we talked about buckets. Let's start with the first one, which is authentication, right? Let's talk about authentication first. Well, that was very easy. Normally, you must have authentication. Well, they didn't have any. So first problem, that API for all public in posts on that social network were just completely open. So any post done by anybody was accessible through that API with zero authentication whatsoever. So that's the first problem.
That is almost unbelievable to me. It's like when you listen to this, it's like, how would anybody roll something like this out? But as you can see, it happens.
Yes, it has happened. It is happening in other cases. We've seen that before in other problems on API Secure.io, and in many cases it comes from this it's linked to that problem of governance of the API. So we leave the stuff open. Maybe there was another breach. I think it was in India at some on a company. Basically, they just open an API for the sake of doing load testing, right? And because they were doing load testing on the same information, they decided to not put any authentication there, so it will be easier to write the test script that would invoke the APIs. And then they forgot about it, and they left it down.
Or, that's a couple of years old now, I think. The Pokemon Go thing, I think that was the same kind of thing, right? Where they thought, well, no, but it's just our app using the API, so why should we do anything about it? And it's like, well, yeah, but now everybody else can use the API as well if they just happen to look at what happens on the network. So.
And that's a critical point there, just without digressing too much, but that's a very key point you just touched on here, which is there is this false sense of what is public? What does public mean, right? And in people's head, public means I've created a development portal. I created my API and I made my API available to the public, right? And that is very different. This is open. This is not really public. The minute you expose something on the internet, it is public. Some automated scanner, if you want to test that, just open any IP on a cloud and system and watch the access log going on. And maybe 5-10 minutes after that IP is up, you will start seeing calls to it. So it is very easy to find stuff online, and the minute it's up, it's public. So even if you're the only one to use it, it does not make it private. It is public. So yeah, that's a very common misconception. So that's the first problem. There is no authentication. Okay, cool. Next problem. There is no and very limited authorization as well. That's actually how we explain that they have been able to take so much data. And frankly, that problem, which is API 1, so it's the first one in the list, right? It's called broken object level authorization, right? BOLA. You're going to hear this about BOLA. Some people may have heard this as IDOR, which is it's a well-known problem, but the APIs have made it much, much worse because of the also REST architecture, right? And what is this saying is, to give an example, would be Isabelle has access to, this is my bank, right? I have an account on that bank. I can use an API to connect to the bank. And once I have a valid token to access to that bank, I can access my account, which is account 123, okay? Happens that Eric is on the same bank and you have account 456. So I should never be able, hopefully, you're in Switzerland too, look at that, right? I should never be able to access your bank account 456 if I know that number, right? Or that's why I'm using simple numbers here, like 1, 2, 3, and 4, 5, 6. As you can see, 1, 2, 3, then I can iterate 1, 2, 4, 1, 2, 5, 1, 2, 6, etc., right?
And just see, it's like, is it working? Is it not working? Right? Just
exactly. So there's tons of problems again on API Secure.io. If you look for IDOR, you're going to find tons of examples of that. And so then in the case of Parler, going back to our friends there, well, very easily, every post that is being done on the social network has a sequential ID, right? So what did the hackers do? Well, write a little engine that just goes and iterates increments by one, and that's it. Get the data, get the data, get the data, right?
Yeah.
So as you can imagine, there's no rate limiting either. They didn't get stopped in their tracks because they got all that data. And the other thing is, this is touching upon, is nobody saw anything. So they were able to evade all that data without being stopped, which means, you know, if something like this happens to you, there should be like a big monitor somewhere in your company that just blinks red like crazy, saying something goes wrong here.
Right. Like high access volume and certain access patterns and all these kind of things.
So you know, all those problems, and that's another point. In most of the large breaches and problems, if you take that top 10, you never have a big breach with just one of them. It's always a combination of things. Like you have a problem with authorization, and you don't have rate limiting, and you don't have any logging. So not only do you have that authorization problem, but you don't slow down people, and you don't see anything happening, right? So that's always a combination of things, right?
Okay, so we've looked at the second bucket then. Now let's look at bucket number 3.
Bucket number 3. Bucket number 3 is misconfiguration and problems around that, right? So as you can imagine, in the wake of what happened around politics early this year in the United States, a lot of people that were on this social network tried to delete any trace of them putting information on there. So what did they do? They went to the UI, say delete post, delete post, delete post, right? And remove it, and then that's it. It was not visible on the UI anymore. Except what was happening behind the scenes there was that rather than really deleting the data, the only thing that was happening is they would just put a flag saying this has been deleted, which means that going around the UI, you would just go and access all that information, right? So that information is still there, so that's a big problem when it should have been deleted. And not only is this information there, it has a lot of information that should not be visible directly, right? Such as the geolocation of where this post had been done from. So imagine yourself, you're at the Capitol, you're doing all these beautiful pictures and videos, and you post them on on the Parler network, right? And then you want to say, no, I was not there. You want to delete it, right? So, well, bad luck. It has not been deleted. So now we know that you had been there because we have the geolocation. So there's a combination of problem again. What should have been deleted has not been deleted. And we're leaking way too much information that we should have been leaking, which is really the number 3 problem in the top 10, which is exposing too much information. Right.
And it's also, again, right, combining this idea that it's only my client using the data, right? So if I put a flag on it that says deleted, then it's good enough because my client will not show it. But then, but through the API, like you said, right, it's still there. It just has a little flag that says somebody tried to delete this.
Exactly. And that's another very key, well, I don't know if it's misconception is the right word for this, but definitely what we were used to in a non-API-based style application, right, would be that all this filtering and all this work of hiding stuff and rendering the data was done server-side, right? And now what we're doing is removing a lot of that logic as moved to the client side. So it's on the client side that we validate if flag equals delete, then don't show, right? Which kind of achieves the same effect that you don't see the data if indeed you're using the right client, but confidently is defeated totally by the fact that if I'm going around the client, then none of that logic is actually available, executed, and therefore I have access to the raw information. And that's a big thing. Like when you start doing design and architecture based on APIs, you have to be careful about where those enforcement and controls actually happen and make sure they do happen all the time on the server side and not on the client side, where they can be circumvented, which is exactly what happened there.
And that's kind of one thing that just moved over from the web application side, right? Where in web applications you would have the same problem, that if you do things just on the client side, then, well, it's clearly visible to others. So
yeah,
it's not something you can depend on. So as we've seen, I think there are many opportunities to do things wrong. And we have this constant stream of examples where this happens, and in more or less damaging ways. Then the next logical question would be, okay, we see this is a actual problem. Now, how do we improve the situation? What would you say, like, where does it, like, should we stop doing APIs because clearly things can go wrong, or what is your advice?
Well, there's a lot of things, right? But the first one is, back to this comment from my customer about APIs popping up like mushrooms, is, we have to stop and think a little bit before we actually do APIs, and think about, what is the data that we are going to expose, and who are we going to expose that data to, right? So the first thing is, in security, everything is about risk. Yeah. So when I'm making a decision to create an API, what is the risk associated to that API? And in the end, depending on, your industry, depending on the information you're exposing. So it's not the same if you're a bank and you're exposing accounts, and if you're indeed, a weather channel and you're exposing the weather, right? Obviously, the risk there is completely different. Although, I've been told once that thanks to the weather information, some people have been able to discover a hidden military base somewhere in the desert from the United States, because it destroyed the weather information. So you never know. So you have to think about
yes.
You have to think about this stuff. So that's the first thing. It's like, stop and think about what is the risk associated and what we're doing. And really this is, and I can't insist more on this. This is a team job. This is really something you have to sit down between the business people, the development people, the security teams, because in the end, they're the ones who are responsible for ensuring this is secure, right? You have to sit together and you have to think and define why and how we're going to do this stuff, right? That's the first thing. The second thing is there's tons of decisions, and I've been giving a presentation recently on this, and I'm sure we can share the link after and you can listen to the details. But there's a lot of design decisions that you will have to take, which are linked to this OWASP top 10. There are things that you are going to define and decide on. How am I going to do authentication? Do I need authentication? And if yes, what is the authentication I need? What is the authorization I'm going to put in place? I will have to put some authorization in place. How am I going to do rate limiting? How am I going to do logging? All those things are really very hard, if not, close to impossible to change once all the code is done and deployed. So once you've gone through the entire development lifecycle and you have deployed things in production, there are some things you have decided there where maybe you're in a position where you have to say, well, we have to start from a blank sheet again and rewrite version 2, thinking about the consequences, and the costs of doing that is going to be really high. You may not even be able to actually justify that you have to do this from a business perspective. So the more you think about, okay, that's how this is going to work, this is how authentication is working, etc. Use that OWASP top 10 and use those problems as a guideline, if you want, as a guiding design guide for all the things you have to think about before you start writing stuff, right? That's for me one of the critical aspects of API security today, because we're seeing people putting some measures in place post production as like a quick thing we put in place because we know we have problems and that's all we can do now. But one of the things we say, at 42 Crunch, and a lot of people say in the industry, is that cannot be the end game. The end game needs that we have to ingrain security within our development. You have to think and have always security in mind when you do, like logging, something as simple as logging. If you're logging tokens just to be able to trace them, a lot of people do that, right?
Okay.
You don't log tokens. People are doing that. Why? Because then it's easy. They can go back to the logs and they can trace from the value of a token. So it seems like a good idea when you start doing it, right?
It's convenient, yes. I wouldn't say good, but it's convenient.
It's a convenient way of doing things,
Yeah.
but the implications from a security standpoint are very high,
Yeah.
right? Especially if you're using things like API keys, which are, in general, have a long shelf life, maybe for weeks, months, even more. Then we end up being hard-coded into applications. We see this all the time, right? So if that is written down straight into your logs, it's going to pop up in a dashboard somewhere for everyone to see. Can't do that. You have to hash them, or you have to do something so you can still use them for doing traceability or observability, but you cannot have them in the clear. That's just one example among N, right? But that's the type of thing that if you have to bolt on a security, some security strategy on top of logging once all your API are written, that's going to be really hard to do, right? So you have to think about this way earlier. And for me, that's the key really thing. It is just to work towards educating people on ingraining security as part of their daily life as developers, pretty much, right?
And I like that message a lot. I mean, we talk a lot about, like, I'm not specifically in the security space, right? But we have the same kind of thing where we say, like, everybody should develop kind of an API mindset, understand what APIs can do for them and why APIs may be a good thing to invest in and so forth. But as a part of that, like you said, it's traditional kind of risk management, right? You also have to understand that you are opening up certain things to certain kinds of misuse or access, and people just have to be mindful of that. And I think just following things such as APIsecurity.io or similar things, right, just help you to just be aware of that. You don't have to be an expert, I would say, but you have to at least understand what the typical errors look like. And this is why I like the top 10 so much, right? Because just going through those top 10 already gives you a pretty good overview of the kinds of things to look out for. And I think that's a good starting point.
Indeed. And it's all about education in the end, right?
Yes.
I'm working with a lot of developers at our customers, because that's basically, as a field CTO, that's what I do. I work a lot with our customers and partners. This is the core of my job. And it's not like the developers are, like, very often, unfortunately, are being put on this kind of all of shame of saying, hey, when the problem comes up, it's your fault because you wrote the code, right? But that is fundamentally wrong. Because the main problem developers have today is, nobody told me, so I don't have the right tools to tell me I've done something wrong, or I have tools that don't really give me too much false positives on analyzing my code. They're like hitting my productivity because I have to release this application for yesterday, not for tomorrow. We're always running after the clock to release stuff. So if people watching this, really, it's really key to invest in educating and helping your developers understand those problems, and again, understand them as early as possible in the life cycle of the APIs, so when they can do something about it. If you tell them, if you develop the entire thing and 2 days before production, we suddenly say, oh, security, go validate this thing, and they will pop up with plenty of problems that just now you're telling the developers when they're like against the wall to release the API. That doesn't go well, right, for anyone. It doesn't go well. It's not good for security. It's not good for development. It's not good for anyone. So one of the things is invest in educating. That's why we're actually doing API Security.io, is to educate. and there's many more things you can do on helping people do secure coding. And also what we saw is there is this disconnect. Let's not fool ourselves, right? There is a big disconnect between the security teams in general and the development teams. They have different, again, goals. They have sometimes conflicting goals in the companies, and traditionally those are not teams that have been, good, I would say, at working together, but simply because, again, they don't have the right tooling and they have the right way and the right language, right? So one thing we've seen, and I'm sure you know, it goes with the API mindset, is what is that common language? How do we get everyone to speak that common language of this is the API we're going to create, that's what it does, etc. And what we found is creating API contracts. So take an API design first maybe approach, whereby we say, hey, this is the API we're going to do, that's what it does, this is the operation, this is the data we're going to expose through it. And the sooner we describe that, the sooner we can all review and work on it, right? And so having that contract as a common language across everyone, being able to look at that contract and right away tells you, hey, from a security standpoint, this is something that could go wrong. Once we have a contract, there are tons of tools around OpenAPI, Swagger, for people who heard it like this, that will help the developers do their work in terms of testing, etc., but also the security people do their work. There are tons of tools now that allow you to do security testing from an OpenAPI file. So that common language and getting those teams to really collaborate and be able to work together, for me, is also very critical to enhance security over time and address really, again, that problem at the root as opposed to after the fact, right? Which is the whole goal here.
Good. I think that was a very passionate and very convincing argument for making security part of your kind of API program or whatever you call what you're doing. But
yeah,
when it comes to like establishing your practices around APIs, like security needs to be an important part of that. Isabelle, thanks so much for joining. I'll link to the longer version of your presentation that has like all the details for the different issues. I also link to apisecurity.io in the description of this video. Thanks so much. And I hope that everybody got something out of it. If you did, please consider subscribing. And once again, thanks, Isabelle, and see you next time.
Wonderful. Thanks a lot. Thank you, everyone. And make your API secure.
Just do that. Okay. Bye, everybody.
Take care. Bye.